Hi, my name is Tara. I'm a designer. I'm currently teaching some students of mine the basics of electronics and coding, and we're building escape room puzzles. And I thought some people who hadn't done electronics or coding before might like to follow along and see what we're doing so that you could make some neat interactive things of your own. I should give you a warning that we're not going to look a lot at the theory of electronics or even necessarily good coding practices because frankly I'm a moron and I understand neither. But what I can show you is just enough to be dangerous, just enough to get stuff done. So the most basic thing we can do first is start with what's an electronic circuit. So the reason that they're called an electronic circuit is if we take something like a battery, like this, a regular AA battery, you'll see that there is a positive on one side, a little plus, and this opposite side is negative. So if we want to power anything with a battery, it has to be connected to both sides. So you have to have the electricity coming out one side, powering whatever it is that we need to use, and then going back in the other. It has to make that full circle. That's why it's called a circuit. So if we look at another kind of battery, this is a little coin cell that I picked up from Pan Shop. And you'll see on one side there it has positive. So this whole front face is the positive side. And then this bit that has this kind of texture on it, this whole part is the negative side. Now this is a 3-volt battery. This normal AA is a 1.5 volt. You can actually see it written on it there. So if we want to power something like an LED, if we want to make it light up, this is what's called an LED. It stands for light emitting diode. And it essentially works like a little bulb, sort of. There's a couple of things to know about LEDs. One is that they need a certain voltage in order to work. So these ones are about, I think about 1.9 volts. We can call it 2 for like roughly. So it needs at least 2 volts to turn on. The other thing is that you'll see that they have a long leg and a short leg. And this long leg is the positive side, and this short leg is the negative side. It only works if it's turned one way around. So if we take this little coin cell again, and we put this long leg onto the positive side and this short leg onto the negative side, like this, you should see that the LED has lit up. Cool. Now if we put it the other way around, so we take the long side, I'll flip it around, put it like that, it doesn't light. If we were going to take one of these LEDs and try to run it off a battery like this, it also wouldn't light because this is only 1.5 volts and this needs at least 2 to turn on. But this 3-volt battery will work for it. So that little connection there, that is your most basic circuit. You have electricity coming out one side, going through the LED, and then back into the other side. Cool. Now, if we want to extend that out into something that looks more like a circuit, like we know them, you can print out this little template, have a connection to, or a link to at the bottom, and we can get something like this copper tape. As this copper tape is conductive, it works exactly the same as wires do, except it's flat and sticky. So if we take something like this, we can cut off a little piece of copper tape like this, and it just has a backing that you can peel off, and then you can stick it down to the paper like a sticker, like this. Now it's important where there's a connection in the template that these pieces of copper have to touch each other, ideally overlap each other. This particular copper tape has a conductive glue, so you can stick the glue right onto the tape. If you wanted to make this with something else like tinfoil, that would work, but you have to make sure that there is a connection between your two pieces of tinfoil. So if you stick it down with Pritt stick or something, you have to make sure the glue isn't in the way. You're probably better off just putting a piece of sellotape across the top. So if we go into here's one we made earlier in a very Blue Peter way. You see this LED? I've just taped it down. So all I've done is take the LED, bend out its legs like this. Remember which one is positive and connect it to the part of the template that has the little positive here. And then put the other leg on the little negative, making sure that the LED is just in the middle without the wires touching. So you just stick it down with a little piece of sellotape across the end. That's all I've done. Now if we go back to our coin cell, like this, you'll see that remember there's a positive on one side, negative on the other, and you'll see on the template there's a little positive and a little negative part. So what we have is if we put the negative side down on this negative half and then fold this over so that the positive side is touching the top half of the battery, if I turn off this light for a second, you'll be able to see that the LED is lit up. Now if I let go of this and break the circuit, it turns off. And that is our most basic kind of circuit. All I've done is taken the LED's legs and I have extended them out. That's all, but it's exactly the same as when we put the LED across the battery like that. You're doing exactly the same thing. It's the same circuit like that. So there are a couple of things to know. There are a couple of basic kinds of circuit. The second one is this, which is called a circuit in series. And what I have here is, it looks much the same, except I have two LEDs, one after another. Now, there is a tricky thing here, don't worry too much about it, but if we use one battery here, it won't work. Nothing will light because these batteries are 3 volts and each of these LEDs takes 2 volts to light. And the first one is trying to use up 2 volts of the battery, only leaving 1 volt left for this one. So overall, they just won't light because these need a circuit with at least 4 volts coming in to light both of them. But just for the purposes of this, go with it. If we put 2 batteries on top of each other like this, we're now producing 6 volts out of these batteries by putting them with the negative side touching the positive side. So we've just made kind of one bigger battery. Now if we put this down here and turn it on, you'll see that both of them light. See? Now the important thing to know about a circuit in series like this is that if we take one of these LEDs out, let me just hold this so it stays on. If we take one of these LEDs off, we just rip it off, the other one doesn't light anymore because now there's a gap and there's not a circuit being made all the way around. The electricity just isn't flowing all the way through. So sometimes if you see fairy lights that have one broken light, they're all in series like this. So the one broken light means that the electricity is not flowing through any of them, and then you have to go through that tedious thing of trying all of the different ones until you find the broken one. The second kind of circuit is this, which is a circuit in parallel. So you can see there's 2 LEDs here and they're connected in parallel to each other. Now, what's interesting about this one is although we needed extra voltage for the LEDs in series, we don't need it for the LEDs in parallel. It'll work just off of one battery like that, and you can see they've both lit up. And what's interesting about this one is that if you take off one of these LEDs, so I'm just going to rip this one off, boop, this one is still lit up because the electricity has 2 routes that it can go from. This one is broken, but this one still works as a circuit all the way around. So that's in parallel. Now, there's some nifty things you can do with just the basic things we've done. So one of the templates that I've put is this one with a switch. And what I've made here is that I have got a little piece of just craft foam, you know, that kind of like foamy stuff you get from pen shops or art supply shops. And I've made a circuit that looks very much like our first one, but I've just stuck 2 little pieces of foam on. Can you see they're kind of 3-dimensional there? And I cut out this little piece and stuck another piece of copper tape across it, like that, and I've attached it to another piece of craft foam. So it's kind of bendy like that, but it springs back into place. Now, if we go back to our circuit down here, and what I'm going to do is I'm going to take this this piece of foam and paper and copper, and I'm going to just sellotape it across this, making sure that like the line would line up with the copper tape that's already there. And just tape it down. And what's neat is if we put the battery on it like that, and I'll turn off the light again so you can see. If I put the battery on it like that, it doesn't light, but if I press here, it does. And then when I let go, it turns off again. So we've made what is called a push button switch, or if you like, if you wanted to make escape rooms, this could be a pressure pad that if you made a really big one with just a tinfoil instead of copper tape stuck on it to bridge this circuit across like that, if somebody stood on a pad like this, it could trigger an output. So that's it. That is the absolute basics of circuits. And next time we're going to look at using breadboards to build similar things and how we might use them in the puzzles too.